Acquiring the principles of mathematics and science. Learning mathematics and science involves more than memorizing facts. It requires developing specific ways of thinking. This often entails undergoing conceptual changes, where individuals must abandon previous notions and adopt new perspectives to understand complex concepts such as heat and temperature. Traditional teaching methods, focused on conveying scientific principles, often fail to facilitate conceptual changes in students. Despite learning definitions and formulae, students may struggle to apply these concepts in practical situations, highlighting a gap between rote memorization and genuine comprehension. Psychologist Piaget proposed that cognitive change in children occurs through their own intellectual activity and encounters with conflicting information. When faced with cognitive conflict, individuals experience disequilibrium, prompting them to reevaluate their existing beliefs and reasoning processes. However, young children may resist discarding their ideas despite contradictory evidence. Piaget's hypothesis inspired the development of discovery learning, where students engage in problem-solving activities to challenge their existing reasoning. Initially, this approach focused on individual exploration, but later adaptations suggested that interpersonal conflict, particularly with peers, could also stimulate cognitive change. Research by Christine Howe and her colleagues explored the role of conflict in group learning environments. They found that children in groups with differing views made more progress in understanding scientific concepts compared to those in homogeneous groups. However, progress was not immediate and often emerged in follow-up assessments conducted weeks later. Another study by Howe investigated the impact of pair work on students' understanding of complex scientific phenomena. By pairing students with varying levels of initial understanding, researchers assessed the effectiveness of collaborative problem-solving activities. Results suggested that exchanging ideas during pair work facilitated conceptual progress in students' understanding of falling objects' trajectories. These findings underscore the importance of active engagement, cognitive conflict, and peer interaction in fostering conceptual changes and deepening understanding in mathematics and science education.